Hey everyone, I wanted to give you a quick walkthrough on Chapter Project 8.5. So Chapter Project 8.5 is going to be just really a culmination of all the things that we've learned so far in Chapter 8 and kind of overall in Module 3. We're going to dip a little bit into Module 1, and you'll see why in a second. So the first thing we got to figure out is how can we get to the resources we need to complete this project. So the first way that you could do it is you could go to the calendar, click on the Chapter Project 8.5 due in the date, and we'll see here at the bottom that it'll open up a link. And so that link just brings me to this kind of block where we have the directions, please share a link or insert a printout of your completed Word document in OneNote. It's pretty straightforward at this point anyway. And then for resources, we've got our template here, our Chapter Project 8.5 document. We've got a link to the chapters 7 and 8 Excel workbook because you're going to need that. This is about confidence intervals, and we know that Excel is going to produce our confidence intervals for us. We've got a link to some data. So we all took a poll recently about whether or not we lived in Texas, and that data is available to us now anonymously per FERPA. Thank you very much. And then we also have a PDF, and this is straight from the office of Greg Abbott, our governor. And it gives us some information about the Texas census and information about demographics in general. So I want to show you the other place that you can get to this part. So if you didn't go through the calendar, you could have scrolled down to the bottom, keep going, keep going, keep going. And we've got Chapter Project 8.5, and it's basically the same blurb that we just saw. So both ways of accessing the information are completely fine. So let's first look at the Word document itself. So when you go to edit this, you will have to download a copy or save a copy. So you want to go to File, and you're going to want to, yours might look a little bit different because I'm the owner of this document, and so it's giving me permission to do stuff. But you, as the non-owner of this document, you will probably have to go to Save As, download a copy, or whatever it is that you need to do. All right, so first of all, definitely fill out your name, very important. And what the project is really all about is just looking at some data and using it like in a very real context. So what we're doing here is we're creating a confidence interval for the true population proportion for Texas residents who were born in Texas. And we call these types of people, or these types of residents, native Texans. I am not a native Texan. You might be a native Texan. So we've got a mix. We sampled 2 sections of stats to get a bigger sample size, which is good. Big sample is good. And that's going to be where our data comes from. So the first question is, well, what kind of sampling method is this? So you might feel compelled to review your sampling method. So if you need a refresher on that, let me show you where you can find that information. If you go to OneNote and you go into Module 1, Section 1.2 was our lecture on sampling information or sampling types and data, right? So you just kind of want to scroll down a little bit, and then we've got a whole big blurb over here about the different sampling methods. There you have it, some examples that we worked out, etc. So if you need to review your sampling methods, go for it. All right, back to project. So that's your first question. And when you're telling me what your sampling method is, I'm just going to tell you right now that it's not stratified. So I'm going to use stratified as my example because it's not the answer. So if you're going to tell me, oh, hey, it's stratified, then you need to explain why it's stratified. So if I were a student and I said, this sample is stratified. Well, it's stratified because we've split the population into strata. naturally occurring strata from within the population. Then from each strata or group, we did a simple random sample in such a way that it preserved the proportionality of the strata as it exists naturally in the population, right? So you've got to have something that shows that you understand the type of sampling at hand and kind of bring it back into the context of the problem. It is not stratified sampling. Don't put that down, be very upset. Alrighty, next what we're gonna do is we're gonna go ahead and read the survey results. So in the block in MOM, we have the survey results here, but they're also embedded in the project as well. So whatever link you choose to access them is fine. So, all right, so here's our survey results. We had 40 responses. 9 people said no, they did not. They were not born in Texas, and then 31% said yes, they were born in Texas. So this is really similar to a homework problem we've seen where we've got a sample size of N, X amount of people responded that they did something. And so your P hat is going to be X over N. So the first step in this project is, well, what is N? What's our sample size? The number of respondents, it's 40. And then X, the number of people who were born in Texas, right? So you're going to get that information from the data that we just saw. And now in part 3, we're going to go ahead and define the random variable P hat. So this really just comes from definitions and from your lecture notes. So if we went back to lecture notes, back to module 3, right? So we've got a whole bunch of kind of info about P hat and what it is and what it's counting. So see if you can figure out what P hat is from within this little blurb. All right. And then the last part of the first chunk where we're collecting the data is we want to state the distribution that we should use to construct a confidence interval for the true population proportion P. So are we going to use a normal distribution? Are we going to use the uniform, the student T, the binomial? So I'll give you a hint. When we're constructing intervals, we've only used 2 distributions to create a confidence interval. We have used the normal distribution, and we have used the student T distribution. So it's up to you to figure out, when do I use the normal distribution? When do I have a Z-score associated with my confidence interval? When do I have a student's T distribution? Or when do I have a T-score? And the other big hint is if you go into, now that you kind of want to create your confidence interval, if you go to 8.3, you'll notice that it's got a P hat squiggle tilde, which means P hat follows or is blank distributed. So this says P hat is normally distributed. That's what that big N is for. Okay, so that is, well, that's the answer. So if you're ever unsure of what distribution you're using for your confidence interval, it's right there at the top. So when we have the population standard deviation, we use a normal, right? We've got a Z-score and I've got the big N. When we are using just the sample standard deviation, the population standard deviation being unknown, I have a big T over here. So that tells me I'm using a T distribution, and I also have a T-score. When I'm using when I'm doing a confidence interval for population proportion, again, I've got this big ol' N right here. So that's going to tell me it's normal. And I've got a Z-score, which also tells me normal. All right, so big hints. In part 2, you are finding the confidence interval. So the first thing we're going to do is we're going to construct a confidence interval for the true population proportion for native Texans. And we're going to use a confidence level of 90%. So in the first part, I want you to write it as your point estimate plus or minus your margin of error. In the second part, I want you to write it as the actual interval. So the high value, the low value. So remember that your point estimate is your number of yeses your number of successes, divided by the total number of trials, or the sample size N. Your margin of error is your margin of error, and Excel will produce that for you. So now the next part is probably going to be a little bit trickier, just kind of technologically speaking. Question number 6, when using a 90% confidence level, how much area is in each tail? So if we look at this chart here, we know that that 90% is the center chunk. So if 90% is in the middle, how much is left over? And now you have to divide that equally in 2 tails. So I just want you to tell me, if you want to list everything as percents, great. If you want to list everything as a decimal, that's great. All I ask is that just stay consistent. So in 6 and 7, if you use percents, all your values for 6 and 7 should be percents. Similarly, actually for 5, 6, and 7, if you list your answers in percents, I want all of your answers for 5, 6, and 7 to be in percents. If you're going to use a decimal for 5, 6, and 7, in any one of those, all of them should be in decimal form. So just pick your format and stick with it. For number 6, I'm asking you to fill out kind of, alpha over 2 is the area of the left tail, CL is the area of the middle chunk, your confidence level, alpha over 2 on the right is your other tail. They should be the same number. And then on the bottom, you've got 3 values. So on the left, that should be your lower value of your interval, your low interval, your first position. The center is your p hat. And then on the right, it's your upper bound for your interval. It's going to be your p hat plus your error bound. So some of you have the ability to draw directly onto this, like say if you have a stylus and a writing tablet. So I can do that. Some of us I know can do that. If you can't, it's totally fine to just draw this on a piece of paper, take a picture, and just insert it as a picture. You can email it to yourself. You can use the Word app, whatever. So that's fine there. I know some of us did that for box plot. So if you did it for a box plot, you could do it for a normal curve. That's another hint. This is a normal curve. Okay. Describe the confidence interval. In 2 to 3 complete sentences, explain what a confidence interval means in general, as though you were talking to someone who has not taken statistics. Pretty straightforward. Not easy, but straightforward. Number 2, in 1 to 2 complete sentences, explain what this confidence interval means for this particular study. And then I gave you like a template for what you could write. You have to fill in some stuff and add some context, but overall the structure's there if you want to use that. Okay, number 3, compare your findings to census findings for Texas. Does your confidence interval support the Texas demographic report's conclusions about the true population proportion for native Texans? What? All right, so why is this question in here? Well, first of all, we're not just creating confidence intervals for fun, people. We're trying to say something about our population. So we have real data from real people, us. We are real people. And we gave honest answers, and that's good data. So we want to know if this data is indicative or representative of the true population proportion. But what is the true population proportion? Like, who has time to ask every single Texan? And the answer is, I guess some people at Greg Abbott's office do. So again, another link to the report, but we also saw that the demographic report was here. So however you access it is fine. You'll get a 2-page, very well laid out report on Texas demographics. And, we see that it's from January 18. This is a census, which means they ask everybody. So it's supposed to be an actual, not a sample, like an actual population. And the reason why it's from 2018 is because that is how long it takes to ask everybody and then to aggregate the data and then to say something meaningful, which is why they do the US Census like once every 10 years or something. That data will be available to you long after you graduated college, okay? So somewhere in here, I'm not gonna say where, but it's on page 1. There is information about the percentage, i.e. the proportion of people who reside in Texas who are native Texans. All right, so it's up to you to figure that out. It's actually a pretty fun little report if you want to read it, only 2 pages. And then the last 2 questions are construct a confidence interval for these varying confidence levels. And we know how to do that. That's just a plug and chug. We're going to change our CL, keep our P hat, keep our N, and then see how all this changes. So you want to list the margin of error and then also the confidence interval. So remember that margin of error is synonymous with the EBP, which is the error bound for the proportion. That comes out in Excel. So we have that. And then you want to list the confidence interval. You're going to use this table to answer number 5. What happens to the error bound for the proportion, the EBP, as the confidence level increases? Does the width of the confidence interval increase or decrease? Explain why this happens. So this is a great question. This would be a really good question to put on the exam. It's another generous hint. All right, well, have fun. If you have questions, let me know. It is due on Monday, November 2nd at 11:59 p.m. But where do we turn it in? You guessed it, turning it in on OneNote. So in your own folder, you're going to have chapter projects. And you'll see that you'll have a section for 8.5. And it's going to go ahead and relist all of these resources, just another place in case you forget something. And all you want to do is when you finish your Word document, oopsies. You're going to want to go to share. And I want you to make sure that anyone with the link can edit. And the reason why is because that allows me to save it and put feedback on it, and that you can see by going back to the link. And I'm the only one who's going to see it, just me. Copy your link. Copy. Go back to your OneNote. Ta-da! Now you're done. So good luck. I'll see you soon.